during the examination. Okay, so accordingly, just do your preparation. Okay, so, means all those formula will be there in the during your end term exam. Okay, the one thing is like you have to just identify which one you have to use and when. I mean, that's something you have to practice. But yeah, rest every formula. I mean the that whole sheet will be there. All test, all distribution, CDF, PDF, everything will be there. Okay, so we are live now. Let me start the session. Okay, I will share my screen and we'll see the question, every question. Is my screen visible to all of you?
Yeah.
Okay, fine. Yeah. So yeah, so mock time has been out. Okay. So let's see. Let's start the discussion. So I will go through each question wise. Okay. Okay. So what very first question says we have 100 samples x1 x2 x100 which are IID normal mu comma 1. Okay. So we have null and alternative hypothesis mu is equal to 0. Alternative is mu is greater than 0. Okay. So what do you mean by mu is greater than 0? Which kind of test is this?
Right side.
Right side test, right? Okay. So can anyone tell me the values? We have x1 x2 x100 normal mu comma 1, right? So this is the very first question. This all are from IID normal mu comma 1. Okay. So okay, so if you see here variance is given to us, right? Right. If the that means we have to use the G test, correct? If I will ask any something rejection acceptance, yes or no?
Correct.
If suppose this is unknown to us, then which test you will prefer?
T-test.
T-test. Great. And we have given the null hypothesis as your mu is equal to 0 and alternative is nothing but mu is greater than 0, right? This is something we have given. And we have given test statistics t equal to x bar. We have to, so what is my test? I will reject my test if t is greater than some constant c. So we have been asked what is the probability of type 1 error. Okay. So, so my test is, what is my test? I will reject my null hypothesis if t is greater than some constant c. Okay. Now, what is this t? This t is nothing but x bar, right? Now, what will the distribution of x bar here? Tell me.
Normal mu 1 by 100.
1 by 100, correct. Because if I have x1 x2 x100 IID normal mu comma let's say this is the sample, this is normal IID normal mu comma sigma square, then x bar will follow normal distribution with mean mu comma sigma square by n. So here sigma is 1, n is 100, correct. Now okay, so do let me know if at any point you are not getting the things. Okay, so what is the very first question? It is asking about what is the type 1 error. If you see question is in terms of C, right? I mean here values is not given to you. You have to just find the probability of type 1 error in terms of C. Okay, so this kind of question you can expect your in your end term exam. I mean this is, you can say it's a important kind of things. I mean this kind of question you can expect that some sample will be given to you and accordingly you have to find. Okay, so this is something you can expect as a hint or something like that, but this kind of question you can expect. So what is the probability of type 1 error? It's a alpha nothing but, right? Correct. And
Yeah.
what is the probability of type 1 error? It's nothing but probability of, tell me, rejecting h naught when h naught is true. And when I will reject h naught, my when t is greater than c. And what is the h naught? Mu equal to 0.
0.
Right? So we have to follow the basic step. That's all. Right now, what is the next step? I should go ahead.
So here x bar minus mu standard form, like
Yeah, I have to convert in standard normal form, right? So now it will be x bar minus mu divided by, if you see what is the distribution of x bar is normal mu comma 1 by 100, right? This is the distribution of x bar, correct? So it will be square root of 1 by 100, yes or no? And c minus mu divided by square root of 1 by 100, and given that mu is equal to 0. Okay. So next it will be alpha equal to, now this term will be what? Z, right? Greater than, and if you put mu as 0, then it will be 0 itself, right? So it will be
Right.
C divided by 1 by 10. Yes or no?
Right.
Yeah.
Yes, sir.
So basically it will be alpha equal to probability Z greater than 10 times C, right? Now what should I do next? Because if you see, options are in capital FG. Capital FG means it should be, it's a CDF form, right? So 1 minus I can do, right? 1 minus probability G less or equal to 10 times C.
Sir,
Yes?
yeah,
Yeah?
just one doubt here.
Yes, yeah, good.
I have a doubt here
Hmm?
that we are saying that Z plus and sometimes we get Z minus some constant, right? So
Z minus, sorry.
see here
Hmm?
in the current step,
Hmm?
we got Z greater than 10C, right?
Yes,
And we are telling that it is 1 minus P probability of Z less than equal to, we are reversing the symbol, like it
yes,
was greater than and
yes,
we making
yeah, yes.
sometime we will get
Hmm.
Z less than some constant value, some value, right?
Hmm.
That time also, should I take 1 minus P and then reversing the symbol? How is that?
No. If see, how will you define your capital F of X? Tell me. This is nothing but probability. Let's say this is A, X less or equal to A, right?
Mm-hmm.
Correct?
Yeah.
This is something. See here, if this is same as X less than A, when if X is continuous random variable, right? In case of continuous, equality doesn't matter what, because probability at a single point is nothing but 0, right? That's why in case of continuous, it's the same thing.
Okay.
If it's discrete, right? Suppose X is discrete random variable, okay? Then if I will write X less or equal to 2, that means suppose X is ranging from 0, 1, 2, for example, just assume. Then you have to add all the probability. Okay, that is the meaning. Okay. In case of discrete, if X
Sir,
is less than 2, then that means X equal to 0 plus X equal to what? But in case of continuous, equality doesn't matter actually.
so my doubt is, in case,
Hmm.
let's say in that place you got
Hmm.
Z less than 10C.
Yes.
Can we directly say FZ of 10C there
Yeah.
instead?
Yeah.
Okay. That
See,
is the
that is
doubt.
the same thing I explained. Just
Okay.
this is, see, that means what? If I'm writing, let's say X instead of X, I have Z less or equal to, I'm saying 10C. This will be same as probability Z less than 10C, which is nothing but FZ of 10C. Why here equality sign doesn't matter? Because this is the continuous case. Okay. In case of continuous random variable, probability at a single point is 0 actually. Got it?
Yeah, actually, I get confused when it is less than this value. We are directly replacing FZ, but
Hmm.
when it is greater than, then we are saying 1 minus probability of reversing the symbol.
It's not a confusion. See, what, first of all, tell me what this capital F represents. First of all, tell me
It
what do
is
you mean?
it is CDF,
CDF.
right? Yeah.
And what is the CDF? How will you define your CDF?
I mean, if we know, I mean, the PDF, then it is integral over the
Forget
normal.
about integral. I'm asking how will you define the fx of A? What this means?
It is that 1 by B minus A, right? If it is,
It's not about uniform distribution. I'm asking what is fx of A? How will you define your CDF? Tell me. Just think how. Okay, what is the CDF first of all? It's a cumulative distribution function. Means
correct.
we have to accumulate the probability. Basically, I will tell you. See, fx of A. Fx of A is nothing but, it's nothing but probability X less or equal to A. That means whatever support of X is there or range range of X is there. This CDF is itself defined as like this. Means we have to accumulate all the probability till point A. Okay. If I want to convert anything in form of capital F, then it should be less than sign, less than equal to sign.
okay, it is the in the definition of CDF. So,
Yes. It's not about just I'm doing hypothetically 1 minus. No. Okay, this is the definition of CDF. Understood? Now, why?
Yes.
If already it's now this is the same as probability X less than A if it's continuous, because in the case of continuous, probability at a single point, it doesn't matter. Okay, I mean it's the 0 actually. Got it?
Yes, clear.
Okay. If it's greater than, I should write it in the form of less than. Okay. So just a second. So now if you see what I can write, this I can simply write fg, and what is this? This is 10 times of c. Okay, is this clear? I think this is the correct answer. Yeah, this one is the correct answer. Okay. Now, according to your query, Biplav, right? So if you
Yes,
see,
sir.
is for example, suppose this mu is defined as mu is less than 0, right? Just assume if this is mu is less than 0, then that means you will get this case, this all sign as a less than, then at this place you will get probability z less than c, which is nothing but fz of 10c. That's all. This will be the answer if left tail test is there, right? Got it?
Yeah, got it.
Right? Yeah, fine. So let's, okay, so most of the people got this as a correct.
Yes, sir.
Fine, great.
Yes.
So let's move to the question number 2, which is probability of type 2 error when HAA is a mu equal to 1. Okay, so question 2 is we have to find the what is the type 2 error, how, what is the notation? It's basically beta, right? I'm defining with the beta.
Reject H0 when H is true.
Correct. So probability of type 2 error is defined as nothing but not reject H0, accept H0. Sorry. Accept null hypothesis when
Alternate.
HA is true.
Alternative
Okay?
is true.
Correct. Okay, so I have given you one terminology. Anyone can remember? For beta, some
Yes.
risk is there, right? Anyone?
Yeah, it's a consumer loss.
Consumer's risk, right? Yeah, great. Okay, so see, when I'm rejecting my H0 here, I'm rejecting my H0 when X bar is, sorry, T is greater than C, right? When I will accept, I will accept if this is less or equal to C, right?
Right.
Yes, sir.
So I'm accepting H0. That means probability of T is less than C, right? Now, if you see in this case, what is my alternative? It says mu is greater than 0, right? But if you see, we have to find the probability of type 2 error for a particular value of mu, right? It's greater than 0, but we don't know. But here is given. Okay, it's given for mu is equal to 1. We have to find this. So far, so good.
Yes.
Yes, sir.
Now, so what is this T? T is nothing but X bar is less than C, given that mu is equal to 1. And what is the distribution of X bar? It's nothing but normally distributed with mean mu, comma 1 by 100. Right? So what is the next step? I have to convert in standard normal form. So it will be X minus mu divided by 1 by 10.
Root. Oh, yeah.
Yeah. Or else, let's say,
Yeah.
C minus mu divided by square root of 1 by 100. Okay.
10.
So now it will be G. Okay, let's put value. Okay, no, not. Okay, please correct me if I'm. Okay, so I have to put the value of mu here, right?
Left portion you can directly say Z.
Yeah. So 1 by 10. Yeah, Biplav, right? Now I think you got it. Now, so this will be Z, right? Less than 10 times C minus 1.
C minus 1.
Right?
Correct.
So what is this now? Now this is already in the form of CDF. So I will say Fz of 10 times C minus
1.
This is your answer. Is this clear? Okay, so this is the correct answer. Okay, what about if suppose I ask 1 minus beta? I mean power of the test.
Then reject H0.
Yeah, it will be rejecting H0 when
HA is true.
HA is true. That means it will be T greater than C, given that for mu equal to 1, right?
Yes, sir.
Let's say I'm asking mu equal to 1. So that means what? Here you have to, now it will be basically, if you see this is nothing but 1 minus Fg of 10 C minus 1, right? And then it will be this. Correct? Are you able to interpret?
Yes, sir.
Fine. So let's move. Yeah, so I mean this the very first two questions, you can expect this kind of questions in your examination. Okay. So question number 3 is, let's move to the next question. X is uniformly distributed over this interval minus A to A. Just to give me a minute. Yeah. So, what's the question? It's a minus a to a, and we have to find the value of a such that probability x less than half equal to 0.7. Okay. So we have given x follows uniform minus a to a, right? For a is greater than 0, we have to find the value of a for what probability x less than half equal to 0.7. Now tell me, how should you approach?
Sir, we could use the CDF of uniform functions.
Correct. There is no need to integrate. I mean, you can do the integration. At the end, you will get the same thing. But you can directly use, because if you know x is following uniform a comma b, then what is the CDF? How will define this CDF? Is nothing but
X minus
probability x less or equal to x, which is nothing but x minus a divided by
B minus A.
right. You can find this from the formula sheet also. Now, so that means what? This is what? This is nothing but, can I say, this is f of half. If you compare, this is small x is what? This is half now, right? Since this is the continuous, equality sign doesn't matter, right?
Yes, sir.
Everyone is getting?
Yes, sir.
Now, so what I will do, x minus a, what is x here? X is here, half, minus a means lower limit. So what is lower limit here? Minus a, right? Divide by b minus a, b is the upper limit, a is the lower limit. So here b is, in place of b, I have a minus of minus a, which is nothing but 0.7. Any doubt? Anyone? Any doubt?
No, sir.
No, sir.
Okay, great. So it will be half plus a divided by 2a equal to 0.7, right? Now we have to just do simple calculation here. So it will be half plus a equal to 2a times 0.7. So it will be half plus a, it's nothing but 1.4 times a, right? So now what it will be? It will be half equal to 1.4 a minus a, which is not how much? 0.4 a, right? So now if you see, what is this? This is 0.5 equal to 0.4 a. Can I say or not? So it will be a
Yes, sir.
equal to 0.5 divided by 0.4, which is nothing but 5 by 4, which is nothing but 1.25. So a value of a is nothing but 1.25. Is this clear? Any doubt?
No, sir.
So you can do the same thing by the integration part also. I mean, because this is uniform, you can simply do minus a into, you can integrate minus a to half, and what is the PDF of uniform, and you will get the same answer. Okay.
1
So
by
you can go with
B minus A.
any approach. Yeah.
PDF is 1 by B minus A, no?
Yeah. PDF is 1 by B minus a.
Yeah.
Okay. Till this point, everything is clear.
Yes, sir.
Great. So let's move to the question number, I think 4. Yeah. So we have two random variables x and y, each have range 1, 2. Okay. And the following formula gives the joint PMF. Okay. What is this? I plus j by k, where k is unknown value, and we have to find the value of 1 less or equal to x less or equal to y is more than 1 and but less or equal to 2. Okay, fine. So what is given to us? They have given to us x and y have both range. That means x is taking value 1, 2, right? And y is also taking value 1 and 2, correct? What is the PMF? Joint PMF is given to us. Anyone can tell me? It's
I plus j by
I
I
plus
plus
j
j
by
k by
k.
k, right? Okay. And where this k is unknown, right? So we have to find out the value of probability. Okay. So probability 1 less or equal to x less or equal to 2, 1 less than y less or equal to 2. This is we have to calculate. So this is something you can do by directly, or you can go with the joint PMF table. It's good to go with the joint PMF table. I mean, then all the things will be very clear. So suppose this is x, this is y. So what is value taken by x? 1 and 2, right? And for y also 1 and 2, right? If you will put 1 and 1, then you will get 2 by k, and 2 for x, 1 for y, then it will be 3 by k.
3 by k.
1 for x, 2 for y, it will be again 3 by k, and then it will be 4 by
4
k.
by k.
Correct?
All sums to 1 now. All
Correct.
sums to 1.
Yeah. So now this is the joint PMF. So first of all, we have to find
12 by k.
what will the value of 1 less or equal to x less or equal to 2, 1 greater than y less or equal to 2. What does this mean? This means, yeah, tell me now. You will tell me.
Y can only take 2 and x can take 1 and
1,
2.
right? That means probability x equal to 1, comma y equal to 2 plus probability x equal to 2, comma y equal to 2. Any doubt?
No, sir.
Right? That means we have to add this value and this value, right? Yes or no? So basically it will be 3 by k plus 4 by k, which is nothing but 7 by k, right? Now the main question, we have to find the value of k. We don't know the value of k, then what? How will you find the value of k? Since this is the joint PMF, all sum of all the probabilities should be sum of all the probabilities should be equal to 1, right? Yeah, someone is saying something. His voice is breaking, I think. Okay, so I will use the property of probability. So sum of all the probabilities should be equal to 1. So it will be 1. Now we will get, we'll solve it. So it's 3, 3, 6 to 8. 12 by k equal to 1. So k is nothing but 12, right? So here value of 12, k is 12 now. So the value of this is nothing but 7 by 12. Okay. I think, yeah. So option number D is the correct. Okay. So this is the answer. Any doubt for this question?
No, sir.
Clear? Fine. So let's move to the very question number 5, 6, and 7. Okay, these are related. Okay, no problem. Let's see. So next question says the standard method of screening for a disease fails to detect the presence of disease in 15% of the patient. To determine if the new method of screening is superior, suppose that 75 people with the disease are chosen at random and screened using the new method. The new method failed to detect the presence of disease in 6 of the patients. Okay, so what will be the hypothesis here?
15% of the patient
Okay.
failed to detect the presence of.
So actually, I went with the second option, but I found this to be wrong.
Okay.
And the third option is correct. Because it is superior, so I thought it will be greater than.
Yeah, third option.
Okay.
Because it's
Yeah,
like
those who chooses third option, why you have selected third?
yeah, the question says that it's sorry, I'm just reading the question. Yeah, it says superior, right? So superior
Okay.
means it should detect. Disease fails to detect. I mean, it should detect much better, right? So,
Okay.
null hypothesis, it says it fails to detect 15%.
Mm-hmm.
So superior means it should fail to detect less than 15%.
Okay. Yeah. Anybody else? Anybody? Any thought?
Sir, why it cannot be like it is not equal to 15%?
Okay. This because of this, it's not. It's clearly mentioned whether it's superior or inferior. Okay.
Hello, sir.
Hello.
Yes. Yeah. Okay. I will take the name. Just go by one. Yes, Darbar. Yeah. Go ahead.
Sir, yeah, I was saying that the new method of screening, the new method of screening failed to detect the presence of six patients.
Mhm.
So, sir, the failed the percentage of failed detection is 8%, and in the standard method it's 15%. So maybe that's why, because the alternate hypothesis must be p is less than 0.15.
Okay, Mansi, you got.
So actually, I got to understand that they are talking about the traditional method, which says that 15% of patient it was unable to detect. If the other method have to be superior, so the with the strength which it was not able to detect should be less than that 15%. That's where the alternative should be less than 0.15. That's my point.
Okay,
And
so
sir, 6
basically, yeah.
patient is less than 15%.
No, see,
But
what? Okay, basically, what?
what I did was out of 75, when 6 are not detected, that comes
Okay,
to
okay,
about
okay.
8%,
Okay,
straight
let me
8%.
see.
So P will be less
Fine,
than
fine.
15, no? Point 15.
Okay, let me give you one scenario. Okay, how we are defining the hypothesis? We are claiming something, right? Okay, I think Rohini, can you mute? Yeah, thanks. So there are some background. Okay, we are defining the hypothesis because we are claiming something. For example, suppose I'm saying I have manufacturing company. I'm manufacturing there. Suppose I'm manufacturing some medicine bottle there. For example, okay. And for example, I'm saying like defective. Defectiveness of a particular medicine bottle is, let's say, in my company is, let's say, 0.10 or let's say 0.10. I mean 10%. And suppose I'm saying there is an analyst, or you came to me and you suppose you felt my claim is too less, or let's say it's a too high. Okay, suppose my claim is too less, then what you will test? Are you getting my question?
No, sir.
Sorry, sir.
So can you repeat once again?
Okay. So suppose I'm saying I have a manufacturing company, let's say it's medicine bottle. Okay. Then I'm saying, I'm claiming that in my manufacturing company, defectiveness of medicine bottle is 0.10. Okay. Then you feel, or suppose there is an analyst, he or she feels that my claim is too less. Then which test you, not test, what kind of claim you are going to test?
P alternate should be p must be greater than 0.5, 0.10, I guess.
Why?
Sir, because we are testing that if your claim is too low, then we are testing about if the claim is like it means it above 0.10, or
We want the
because
claim to be
they
more
think,
than 10%.
yeah.
Correct. That is the something I was trying to say. Okay. Now is this clear to everyone? Sir, I'm
Yes.
saying new method of screening superior, right? Then you must be tested. It's less than 0.15. Okay. Suppose I'm saying you determine if the new method of screening is inferior or less or something like that, then your B option will be correct.
Yeah, percentage increases in that
Correct?
case.
Got it?
Yeah.
Yeah. So let's move. Okay. So this kind of question you can get, like what kind of hypothesis will be there? Some sort of scenario is there, then what kind of hypothesis will be there? Okay. So your option number C is the correct one. Okay. So next question is find the p value of the test. Okay. So what is the p value? I think question number 6 is there, right? So for question number 5, correct is option number C. Okay. H0 is nothing but p is equal to 0.15, and alternative is nothing but p is less than 0.15. Okay, so what is the p value, anyone?
When your test statistic is equal to the critical value.
Okay. What about others?
The least value where you will accept this.
Correct. I will reject my null hypothesis when null hypothesis true. Correct. Fine. Okay. So let's move. Question says we have to find the value of p. We have to find the p value for the test. But before find the value of p value, so okay, if this is your hypothesis, first of all, what will be my test?
You have to take t less than c.
T less than C. Okay.
Yeah.
Okay. So, but what is your T? That is the main question.
X bar, sir?
X
Okay,
bar by, it is a jet test. So X
Okay.
bar minus mu by sigma by root n.
No, what will be your X bar then? What
X
kind of
bar here, okay.
That will be 6 by 75, sir.
No, see here, if you read the question carefully, first of all, tell me by reading the question, forget about jet test and all. I mean, to converting standard normal. Tell me what kind of distribution is there?
Sir, it is binomial
It's a
distribution.
binomial, right? Binomial for 75 people, Bernoulli for ith people, right? Because if you see for ith people, right, there will be two cases. Either it will detect or it will fail to detect, right? Yes or no? Only these two cases will be there, correct? You can define for 1, you can define for 0. Now, how many samples they are going to take? 75 samples, right?
Sir,
They are taking, yes?
ith people, sir?
ith people means how many samples they are taking? They are going to take 75 people, right? Or
Yes.
any of the ith people, it can be, I mean, here I can take any value, 1 to 75. I mean, it means first person, second person, third person, up to 75th person, okay?
Okay,
So for ith people, it can be detected or it cannot be detected, right? So now you know sum of NIIT Bernoulli random variable is what? Binomial. Yes or no?
Yes, sir.
Then if I will add x1, x2 plus till x75, then what it will be? It will be binomial. What will be parameter?
75.
Comma P, right?
Okay.
And you can, yeah, so there are two things. You can define your T here like this also, or you can define your T as X bar also here. I mean, you can go with any one approach. It will not affect the answer, okay? But let's go with the, which one we should prefer, X bar or T?
X bar.
X bar?
Yes,
See,
sir.
okay, let me tell you this one also. If you are going to this one, then it will be T less than C give under H0, right? Then what will be the distribution of T? Since n is large, then it will be normal. What will be the mean? 75p, 75p 1 minus p, right?
Yes, sir.
Okay. Everyone is getting this point? How I am converting this one?
Yeah.
Agreed, yeah.
Okay,
Yes.
fine. If I will move to the, let's say, X bar part, then X bar means it will be X1 plus X2 plus so on, X75 divided by 75, right?
Yes, sir.
What will the distribution for this?
It will be normal mu comma
No, not mu here. What is this
P
distribution?
comma
4.0 p. Yeah.
P comma
P into P 1 minus P.
P into 1 minus P divided by 75. Right? Anyone who wants how I will get this one, I can derive.
Yes, sir. Can you explain that one?
This
Like,
one?
yeah.
The
P
above
and
part
P.
you got NP into NP 1 minus P.
Yes, sir. That one I got, but this one I didn't understand.
Okay, actually here we are just finding the mean of this one. Okay, basically if you see what will the expected value of X bar, that means expected value of 1, like see 1 divided by 75 I can take outside, right? Then it will be expectation of X1 plus X2 plus up to
It will be
75,
NP by 75, I guess.
right? What is the
Yeah.
mean for everyone, every exercise,
Okay, I got it. 75 P by 75 it will be.
right? So it will be
Yeah.
NP, no, it's only P, right? For ith people, it will be P, right? If it detected, right?
Yeah.
It will be 75p divided by 75. It will get cancel
Okay.
out. So expected value of X bar is P, which is, this is the same, right? And
Okay.
same if you do for variance. Since
Then we
these
can.
all are IID, it will be 1 upon 75 square, right? And variance of each 70, I mean, each exercise. Yes or no?
Okay.
And what is the variances for each variable? Tell me, for each Bernoulli, it's a P into 1 minus P,
Yeah.
right? So how many times this is P into 1 minus P? It's a 75, right? So this will get cancelled out and you will get P into 1 minus P divided by 75. This is something which we I have written here. Okay,
So
so in,
basically, in that upper one, we are like finding the mean, mean and I mean, expectation of x bar and expectation of variance and like ऊपर में मतलब हम लोग वो find कर रहे हैं full distribution.
see, both is the same, right? Anyway, for x bar, I'm going to find the what kind of distribution is this, right? See, if I know if n is large, it will be normally distributed, right? Correct. Then what is the mean? Mean is this. What is the variance? Variance is this. So any test statistic is fine. Whether you can go with the x bar. The only difference is if you're going with the x bar, you have to subtract p and divide by this case, right? If you are taking your test statistic as t here, then you have to subtract the mean and divide by this standard deviation. That's all. That is the only difference. Okay.
Okay. Sir.
Now, so my hypothesis is our hypothesis is here. It was, I think, p was 0.15 and alternative was p less than 0.15, right? So I'm going to proceed with that part itself. Okay, so first of all, what is the C in my question? See, when you will reject, new method failed to detect presence of the disease in the 6 of the patient, right?
0.08.
So basically my alpha is not alpha. My p value is, what is probability of rejecting H0 when H0 is true, right? Now, when I'm going to reject my H0 for this case, I'm taking X bar, right? X bar is less than C, right?
Sir, is the p value and significance level both same?
Okay.
Yeah, I have same doubt.
I will, someone told me just few seconds before. Anyone? Okay, that person wants to explain.
Sir, here we take the test statistic and equate it
No. Question is either p value and alpha
is same. Actually, from the graphical presentation earlier, what I understood is right hand side. Let's say it is a right test. Somewhere we get the alpha. For the right side, we get p, which is the nominal value where we decide whether to accept or reject the test.
Okay.
I didn't get it, sir. Like,
see. Basically, thing is that I think you should watch the lecture. If I'm not wrong, it's 11.5 or 11.6. Okay.
Yeah.
Basically, p value is nothing. Okay. What is the alpha first of all? It's a significance level, right?
Level.
Okay. So p value is nothing but it's a basically lowest significance alpha. I mean, at which your null hypothesis will be rejected. I mean, see, suppose I'm saying, let me do a graph here. Let me draw a graph. Okay. Suppose this is, I mean, just consider as a bell-shaped curve. Okay. It's not properly drawn here, but just consider. So peak is at mu. Okay. Right. Now, suppose I'm saying, let's say, I'm saying this is the one of the C. Okay.
Okay.
Okay. Then after this, I will reject my H0. That means this will be alpha.
Yes, sir.
This dotted region.
Yes, sir.
Right. Suppose I got one value C dash any value, right? Okay.
Yes, sir.
That means after this, it will be some alpha transpose. Just consider, right? So that means this region will be the P value actually. Okay.
So basically, it's the lowest critical,
yes.
lowest critical value for which we get the minimum amount of error or minimum amount of rejections.
Correct. Basically, at which I will reject my H0. That is the P value. I mean, it's nothing but lowest significance level at which I am reject my H0. Okay.
Okay.
Definition is the same. Rejecting H0 is true, but thing is that it's the lowest significance, not the okay. So when I'm rejecting my H0, if I'm talking about X bar, so here X bar is less than C, and what is the H0? P is 0.15, right? And what is the distribution of X bar here? We got X bar is normally distributed P, comma, P into 1 minus P divided by 75, right? Now, what should be the next step? So what is the C first of all?
What? C should be 0.08 maybe.
I think it's 6 because that's what
6 divided by 75 from the question. Okay, so it's a 0.08. Okay, it's given to me. Okay, so I mean x bar is less than c, so it will be, that means x bar is less than 0.08, given that p is equal to 0.15. Then what is the next step? I have to convert in standard normal form. So it will be x bar minus p divided by square root of p into 1 minus p divided by 75, right? Less than 0.08 minus p divided by square root of p into 1 minus p divided by 75, right?
Yes, sir.
Okay, and what is the given case? Given that p equal to 0.15, right? So now what will be this term? This term is nothing but, okay, let's put the value of p also. Anyway, this term is going to be j, right?
Z.
Z, right? It will be z less than 0.08 minus 0.15 divided by square root of 0.15. 1 minus 0.15 divided by 75.
Yes,
I
sir.
just substitute the value. Okay, anyone have calculated this value or
0.08 minus 0.1.
anyone have calculated? Can you calculate it and let me know?
It is 1.
Minus 1.69.
Minus 1.69.
69.
Okay, thanks. So that means what? This is nothing but fz of minus 1.69. Right?
Yes, sir.
Correct.
Yes, sir.
So is that value given to us? Yes, in the beginning. So fz minus 1.69 is nothing but 0.04, right?
Yes, sir.
Correct. So 0.04 is the, basically it will be the answer of this question. Okay. So 0.04 is the p value. Okay.
Sir, then I have a question, that is, how do we then differentiate between this significance level and p-value? Because if we like if we take the significance level to be 0.15, then will it be the significance level? Like if we take the c to be 0.15.
No. How? Okay. Why you are taking c as the 0.15?
Okay, sorry, but sir, I don't like right now. I don't understand like why it's p value and why it's not significance level alpha.
Sorry. Can you repeat?
So,
Why is the?
sir, why the answer you got right now from this hypothesis testing? Why the answer is p value, not alpha?
What is the question? First of all, question is asking about p value, right?
Yeah.
What is the p value? Is the lowest significance. That means, see, what do you mean by this 0.04? That means you are rejecting your null hypothesis as 4% level of significance.
Yes, sir.
Okay. If I'm writing 5%, 10%, suppose I'm rejecting null hypothesis at 10%. Okay. And I'm able to reject my null hypothesis at 4%. That means this is the p value. It's the lowest significance alpha. I mean, see, alpha is nothing. Alpha, suppose I'm defining, I'm able to reject my null hypothesis as 5%.
Yeah.
And p value I'm getting here 4%. That means it's the lowest significance, right?
Okay.
Okay, just try to understand this graph. I'm saying this is the my critical value. This after this, let me use another color. This red region is the my alpha, whole alpha, right? If suppose for example I got any value, let's say this, so this yellow one, right? So this yellow one, if I'm able to reject it, that means this is the p value. That's all.
So it's basically the average C is like the alpha and the lowest C value is like
p value. Yes.
Okay. So if you have taken the C at 0.05 or 0.010, then it would be like alpha.
C, you have to find out from the question itself, right? It's not about if C is like this. So see, this is I have calculated from the question. It can be anything. Okay. It's not about it will be like this, then it will take alpha, but it's depend on the question. Okay.
Okay, sir. Understood, sir.
So what? Okay, now tell me, will you accept or reject your null hypothesis at a significance level of 5%? What will your conclusion here?
We'll reject it.
Reject?
We will accept it, sir.
Why?
Because the lowest C value is like 0.04. No, it's 4%, I guess.
Sir, reject.
It's a reject, right? I will reject my H0. Just think, what is this P? P value is the lowest one, right? It just assume 4% is this one, right? And this is your 5%. Then you will reject or accept?
Oh, we would reject, sir.
Right. And also, if you see the value, actually, it's nothing but 0.05 itself. Anyway, because we have to round up two decimal places, so it will be 0.05. Okay. Understood?
Okay, sir.
Oh, fine. So, should we move to the next part?
Yes, sir.
Yes.
Okay. Yeah. So just give me a minute. I will be back in. Okay, fine. So next question is, we have given x is a discrete random variable with following PMF, -2, x is taking value -2, -1, 0, 1 with this probability p by 2, p by 2, 1 minus p by 2, 1 minus p by 2. And we have given the sample, this random sample -1, 0, 1, 1 minus 2. For this, we have to estimate for this given of this given sample, we have to find the estimate of a P with the help of method of moment and with the help of maximum likelihood, right? So just tell me the value -2, -1, 0, 1. So question number 8 is there. Okay, so x is taking value -2, -1, 0 and 1, right? And with the probabilities p by 2, p by 2. Okay, so p by 2, p by 2, 1 minus p by 2 and 1 minus p by 2, right? And we have given the samples -1, 0, 1, 1 and 2, 1 and -2. Okay, this is the sample. We have to estimate the estimate of P with the method of moment, right? So what is the method of moment says? Moment estimator. We have to equate the sample moment to the population moment, right? Now, this is the one parameter. Then I need only one equation. That means I will take M1 equal to expected value of X. That's all. Right. And what is the expectation of X? How I will calculate? I will calculate from the distribution part. Okay. Now, what is this expectation of X? How will you calculate? So expected value of X is nothing but summation of X into respective probabilities. So that means -2 into p by 2 minus p by 2 plus 0 into 1 minus p by 2 plus 1 into 1 minus p by 2. Any doubt?
No, sir.
It will be -3p by 2 plus 1 by 2 minus p by 2. I mean, this will be 0. I have just separated the terms. So it will be half minus 4p by 2, right? That means half minus 2p. So this is the expected value of X I got, correct? Yes or no? And what is the M1? Tell me. M1 is nothing but 1 upon n summation of xi, right? This is the something M1 has been defined, right? And what is the, this means what is this xi? This xi is from the samples, right? How many samples we have? 8, I mean 1, 2, 3, 4 and 5, right? That means -1 plus 0 plus 1 plus 1 minus 2 divided by how much?
5.
So it will be 1 will give -1 by 5. This is M1. No. Now what is the our I mean method of moment says we have to equate sample moment to the population moment, I mean distribution moment, right? So that means it will be minus 1 by 5 equal to half minus 2p. Now from here it will be 2p equal to half plus 1 by 5, which is nothing but 7 by 10, right? Now it will be 2p is equal to 0.7. So p equal to 0.7 by 2, which is nothing but 0.35. So we got estimate of p with the method of moment estimator, which is nothing but 0.35. It should be the answer. Yeah, 0.35 the answer. Is this clear? Any doubt?
No, sir.
Okay, what if x is the continuous random variable? Then how
We
will you find
integrate.
the expected value of x?
We integrate over like.
Correct. Over the given things, right? Given range of your, I mean, support of your x, right?
Yes, sir.
Okay. So now this kind of question you can simply expect. I mean, I think in term will be easy for you guys. Okay. So, I mean, you can expect this kind of question. It's a kind of important. You can expect the alpha and beta first two questions. And
Excuse me, sir.
for the given question, what will be your hypothesis? Something like that you can simply
So my experience with NTERM is like it is always different questions than mock. I've always practiced mock test question and the questions are much tougher like from the mock.
No, it will not be tougher. You can force it.
Excuse me, sir.
Yes.
Sir, you just told us about the continuous case, like what will be done in continuous case, but I'm not really sure about it. So could you please briefly explain what would be done in the continuous?
Basically, suppose this is the discrete case, correct? Then you can find the expected value of x is like this, right? See, this M1 is same, right? Anyway, you have to use the sample values for M1, right? I'm asking about expected value of x. If x is the continuous, how will you find the expected value of x? If discrete, then you are finding summation x into px, right? If it's continuous,
okay, then we'll integrate over.
Yeah, that's
it
all.
around.
I mean, you have to
Yeah,
integrate over the whatever the PDF will be there. You have to find the expected value of x and just equate this with the M1. That's all.
Okay, this only. Yeah. Okay.
Yeah.
Okay,
Yeah,
sir, understood.
yeah. So next question is what is the maximum likelihood estimate? Okay, what is the method of maximum likelihood estimate? Okay, let me write down all the values: -2, -1, 0, 1, with probabilities. Okay, I think it was p by 2, right? P by 2, p by 2, 1 minus p by 2, and 1 minus p by 2, right? Now, what are the samples? Samples are -1. Right, samples are -1, 0, 1, 1, 2, -2. Now, what is the likelihood says? That means product of all the things, right? Fx of xi, right?
Yes,
that
sir.
means fx of x1, this fx of x2, fx of x3. How many samples we have? 5, right? Yes or no?
Yes, sir.
I have only 5 samples, right? Then what is the probability for this -1?
P by 2.
And only one time is there, right? -1. So p by 2, right? Into for 0, 1 minus p by 2.
1.
Right? And 1.
1 minus p by 2.
So 1 minus p
whole
by
square.
2 into 1 minus p by 2.
Into 1 minus
right?
p by 2.
For -2, p by 2. That is something I have to do for likelihood, right?
Yes, sir.
So it will be p square into 1 minus p raised power cube divided by 2 raised power 5.
Yes.
Correct? Yes or no?
Yes, sir.
Now, what is the next step?
Log.
We differentiate it.
No. Before differentiation, I have to take the log because maximizing the likelihood. Okay, it's the same as maximizing the log likelihood. So log of L, that means it will be log of p square plus log of, basically it's a natural log, 1 minus p cube plus log of 2 raised power -5. Yes or no?
Yes, sir. Yes, sir.
It will be
minus.
2, yeah, 2 raised power -5 I have written. Okay, 3 log 1 minus p minus 5 log. So anyway, it will be 0 because now what is the things we have to integrate with respect to p, right? So not integrate, differentiate. No one corrected me.
Differentiate.
So it will be 2 by p
2 by p
plus 3 by 1 minus
3
p.
upon 1
And
minus p.
again differentiation of 1 minus p, it will be minus 1, and this will be 0, right? Now this thing I have to equate with the 0.
0.
Correct. So what will the next? I think it will be 2 by p minus 3 divided by 1 minus p equal to 0. Now what's next? I can simply do these things, right? I think someone, Rohini, can you please? Yeah, thanks.
Sir, I have a silly question, if you don't mind. That is, sir, I've forgotten this differentiation. I don't understand where that -1 came from, because I have seen one of the revision sessions of like there also that the professor has said that there is a -1. I don't understand
But
that
I
one.
think you should then brush up on differentiation, right?
Yeah, I have to brush up those like.
Yeah, basically, I will give you the hint. Hope it will
Yeah.
help you. Basically,
Yeah.
suppose there is something log of x, right? And I have to differentiate with respect to x. Then differentiation of log of x is nothing but 1 by x. Okay.
Yes, sir.
You are differentiating x for the log of. If suppose there is something d of dx log of 1 plus x, for example, right? Then differentiation for this it will be 1 plus x. Okay. Since we have to see these things and this thing should be same actually. Okay.
Yeah.
Since both are different, that means I have to differentiate this 1 plus x again. If you will differentiate 1 plus x again, that means you are doing d of dx for 1 plus x. Then d of dx of constant will be 0 plus d of dx of x. It's a 1. Okay.
Okay.
It will be
Okay.
into 1. Now it's a minus, then it will be minus.
Okay, I get it, sir.
Okay. Yeah. Let me erase this thing. Fine. So yeah. So it will be 2 1 minus p equal to 3 times of p. It will be 2 minus 2p equal to 3p, which is nothing but 5p equal to 2, right? So p hat will be what? 2 by 5. This is nothing but 0.4. So p estimate of p with maximum likelihood nothing but 0.4. Okay, this is the answer. Is this clear? Any doubt?
No, sir.
Fine. Okay. So let's move to the next question. Question number, I think. Which question is this? 6, 7, 5, 6, 7, 8, 9. I think it should be 10. I think marking is not there. Okay, so let's move to question number 10. Let's see what it means. A company has installed 2 machines, A and B, to fill the oil in bottles. Standard deviations of the amount of oil from machines A and B are 0.6 and 0.5 liters respectively, right? That means I can say sigma A is 0.6 and sigma B is 0.5, right? Let's write down the things, whatever the given to us. So sigma A is for machine A, sigma A is what? 0.6, right? And for machine B, sigma B is means standard deviation is 0.5. Now, the company manager suspects that average amount filled by the 2 machines in bottles is different, right? Now, he took n samples from machine A and found the average to be 1.2 liters. Okay, that means he took n samples, right, from machine A. And what is the average? 1.2. What this 1.2? It's x bar or mu?
X bar.
X bar, right? Now, found the 1.2. A sample of 50 bottles from machine B results in an average amount of 1.6 liters. And he took a sample of 50, right? And what is the amount? Average amount is 1.6. Let's denote this y bar for the machine B. If the p value of the test is 0.01, find the value of n. And that means p value is given to me. P value is given to me, which is nothing but 0.01. What we have to find? We have to find the value of n. That is the question. Now tell me which test you will apply here. by saying the question itself.
Z test.
What kind of Z test?
Two samples.
Okay, why we are taking two samples? Because it's given for two different machines, right?
Square test.
Okay. So basically we have to check for the, I will apply two sample. Okay, why G test? Why not T test? Why we are
Variance is known.
Yeah, standard deviation is the known. Okay, what will the hypothesis your here?
Both the amounts are different.
Mu A equal to mu B? Yes or actually, whenever we are writing the hypothesis, we have to write in the form of population parameter. Okay. Now, so what will be your alternative?
Mu A not equal to.
Okay, it's not okay. There is not any information which machine is better, which machine is superior, which one is inferior. I will take. Basically, that means this is the two-tailed test, right?
So how did we get this mu A is equal to mu B? It is not given, no?
Okay, that's why I asked, how will you define your hypothesis? Means on an average, I will take, there is no significant difference between the for the machine A and for the machine B, right? Because we see there are two different samples, right? It's not about only one sample. Suppose if we are talking about only for a single machine, let's say it can be A, it can be B, and I'm saying on an average, let's say it's let's say 1.5, for example, just assuming, right? Then I will apply a single one sample Z test. Here I'm talking about two different samples. Okay, so whenever you have two different samples, our hypothesis is defined as mu1 equal to mu2. That means there is no significant difference for both samples. Okay, alternative we will define as for the information. Okay. So okay, if there is two-tailed test, what will be your test when you will reject your H0? I will reject H0 when? If
modulus of y bar minus x bar.
Yeah, y bar or x bar minus y bar, both is the correct, is some greater than some C, right? Now, okay, so if I'm saying x is following normal mu comma sigma square, right? Then what is the distribution of x bar?
Mu comma sigma square by n.
N, right? For this one very first sample, what will the distribution of x bar for machine A? What is the mean? Mean is, let's say, mu A, right? What is the sigma square? 0.6, right? So 0.6 square divided by n. Correct? Now, same case for machine B, what will be y bar? Let's say y bar. It will be mu B comma
0.25 divided by.
Okay, what is the sigma square? 0.5 square divided by
50.
50, correct, because n is given to me in case of y bar, right? Correct, so 50. Now tell me, what about distribution of x bar minus y bar? X bar minus y bar, it will be normal. Tell me, what will be the distribution?
Mu A minus mu B.
Correct, mu A minus
sum of variances.
Okay, then
Sigma,
0.6 square divided by n, minus or plus?
Plus.
Yeah, be clear with this. It will always be plus. Okay. Now we got the distribution of x bar minus y bar. Now what is, we will use the p value. P value is given to me. Probability of, what is the p value? Probability of rejecting H0 when H0 is true. And this is nothing but 0.01, right? This is given to me. Yes, 0.01. Now I will proceed with this. And when I'm rejecting my H0, modulus of x bar minus y bar greater than some C, given that what is the H0? I'm assuming mu A equal to mu B. So far so good. What is the next? I have to convert in the
standard
normal form. So that means what is the mean? I have to subtract these things and you have to divide the square root of this quantity. Correct? Yes, so everyone is getting this point, right?
Yes.
So it will be x bar minus y bar minus mu a minus mu b, right? I am subtracting this mean divided by square root of 0.36. I'm writing, okay? So 0.36 divided by n plus 0.25 divided by 50 greater than, yes, Subrat?
Sir, I just had doubt in this equation that how did you do this mu a minus mu b and add the standard deviation? Like,
It's a basic calculation. Okay, I will tell you. One second. Let me write these things. Okay.
Yes, sir.
Okay. Now, is this clear so far? This part?
Yes, sir.
Okay. Now, this is nothing but 0.01. Okay, so basically, tell me where I should write in the continuation part. Okay, I will write here still, then I will read it. Suppose I'm saying x bar is following normal mu1 comma sigma 1 square divided by n1. Okay.
Yes.
And y bar is following normal. It's a basic calculus. I think you people should. No problem. Suppose this is case, right? What is this? This is expected value of x bar, expected value of y bar, variance of x bar, variance of y bar, right?
Yes, sir.
Now I'm asking distribution of x bar minus y bar. That means what will the expected value and what will the variance? Now, expected value of x bar minus y bar means what? Expected value of x bar minus expected value of y bar.
Yes, sir.
I can do mu1 minus
mu2.
The same thing, mu a minus mu b, right? Variance of x bar minus y bar. Now you will tell me. Suppose both samples are independent.
Variance of x bar minus variance of y bar.
This will be this will be right.
Yes, sir.
Are you sure? Just think.
It should be plus.
It should be plus. Why? I will tell you because variance of x bar plus I can write minus 1 times of y bar. Okay. So be clear with these things. So variance of x bar plus variance of I can write minus 1 times of y bar. Okay.
Yes.
So since variance of ax, a is any constant, it will be correct. So it will be variance of x bar plus minus 1 square of variance of y bar. And what is the variance of x bar? Sigma 1 square n1 minus 1 square will be 1 and variance of y bar is sigma 2 square and 2. That is the same thing I have done. Got it?
Yes, sir.
Yeah. Just give me a second. I'm erasing because of that continuation of the solution of that particular question.
This becomes z and this becomes j.
Just give me a minute, please. So basic thing is we are converting the standard normal form, right? So we have to subtract the mean and we have to divide by the standard deviation of that random variable. That random variable can be x, that random variable can be y, it can be x bar, y bar, and anything. But key thing, we have to subtract the mean of that random variable and divide by standard deviation of that random variable. Okay. So far it is okay. Now what is this? Mu a equal to mu b, right? That means this will become 0. If you will put mu a equal to mu b, that means 0, right? It will be 0. Yes or no?
Yes.
Okay, what is it? This is modulus of z greater than c divided by square root of 0.36 plus, divided by n plus 0.25 divided by 50, right? And this is nothing but 0.01. So far, so good? Yes or no? Any doubt?
Yes.
Okay. Now, one more thing. What about C? C is given to me or not?
No, sir.
C is not given to us.
So we are given the average amount that you found by sampling. Can we like subtract both of them to get the value of C?
Sorry?
We are given the average amount that he found by experimenting.
Okay.
So if we subtract like the average of A
Correct.
by
Basically, that is from, yeah, that is from the sample, sorry, question itself, right? So what will the value of C by that information?
0.4.
Yeah, so value of C is the 0.4. Is this clear to everyone?
No, sir. Can you tell me, like, I didn't understand that. But
Okay, basically I have 1.6 minus 1.2, right? Okay, so basically we are, see, C is nothing but just a constant value, right? So I'm observing, I'm saying modulus of x bar minus y bar is greater than C, right? And that means I'm saying modulus of this C is nothing but modulus of 1.6 minus 1.2. It should be greater than 0.4. Then I will reject.
okay, so it's just the subtraction of the both of the sample mean.
Or also, if you see from the previous question here, how did we find the value of C? Here we were talking about the proportion P equal to 0.15, right? Then we found the value of C from the sample itself, which was the proportion 6 divided by 75, right? Got it?
Yeah, sir.
Okay, yeah. So value of C is 0.4 itself. Okay, so let me write down, it will be mod G greater than 0.4 divided by square root of 0.36 divided by n plus 0.25 divided by 50. Now tell me, what should I do now? It's not only G, I will write 1 minus probability Z less or equal. What should I do now? It's the modulus of G.
It will be 2 times FZ minus that number.
Which number?
This which is 0.4
Okay,
divided
okay.
by
First of all, basically, okay, do let me know.
It will be 2 times F inverse of that value. 1 minus F inverse.
F inverse of that.
1 minus 2 times F inverse of this value.
It's a positive or negative one. It's a negative one. I will tell you how.
Yeah,
Okay, if modulus of G is greater than this, means that means I will write modulus of G greater than this things 0.36 divided by n plus 0.25 divided by 50, or I can say Z is less than minus 0.4. Yes or no?
Yes, sir. Yes.
Yes, yes.
Right. So this is nothing but 0.01. This is given to me. Now, if you see the, okay, if this is OR sign, that means I can add. Yes or no? See, probability A or B, that means probability of A plus probability of B. Yes or no?
Yes, sir.
Yes, sir.
Right?
Yes, yes.
So it's a 0.4 minus 0.4 divided by square root of 0.36 divided by n plus 0.25 divided by 50, and this is whole things equal to 0.01. Now, if you see, I have to convert in standard normal form, but this is the greater than sign. To convert in FZ value, I need less than. Now, if you see the normal distribution curve, right? It's a bell-shaped curve, right? Correct.
Yes,
Suppose I have this point as a minus A and this is the point as a. Okay. So this is the symmetric curve, right? So due to symmetricity, this part will be equal to this part. That means what I'm trying to say, probability of Z less or equal to minus A. This is same as probability Z greater or equal to A. Yes or no?
Yes, sir.
Yes.
I can do, right? Now, if this is the case, suppose this whole part is A. I mean, this 0.4 divided by square root of 0.36 divided by n and all, it's a. Then I will say this part is same as this one.
Yes, sir.
Correct?
We can equate it.
Yes, I can equate it just because of this symmetricity, right? Then I will say probability Z less than. See, I can write equal to sign or also not also, because it's a continuous random variable, right? So in case of continuous, that equality doesn't matter. I mean, why it's not matter? Because probability at a single point it's a 0. Okay, so I will write this case, okay, minus 0.4 divided by square root of 0.36 divided by n plus 0.25 divided by 50 plus probability of G less than minus 0.4 divided by square root of 0.36 divided by n plus 0.25 divided by 50, which is nothing but 0.01. So far, so good.
Yes, sir.
So this will be 2 times of probability G less or equal to minus 0.4 square root of this whole
0.36
quantity,
divided
right? So it's a 0.01. Now it will be 2 times fg. I can write because it's already in less than side, right? Yes or no?
Yes, right.
Okay. 0.36 divided by n plus 0.25 divided by 50, which is nothing but 0.01. So now this 2 I can transfer to the right hand side. It will be 0.005, right? So it will be fg minus 0.4 divided by square root of 0.36 divided by n plus 0.25 divided by 50 equal to 0.0 divided by 2. This is 0.005. Now what next? I can, yeah, it will be minus 0.4 square root of 0.36 divided by n plus 0.25 divided by 50 equal to fg inverse of 0.005. These things we have to see. It should be given there. Fg of 0.005. Yeah, so minus 2.58, right? Everyone is getting how I'm calculating this value? So it will be minus 2.58, right? This is minus 2.58, right? Yes or no?
Yes.
Okay.
Yes, sir. Yes.
So minus sign will get cancelled out, right? From the, okay, let's make it this as a equation star. Not equation. Okay, okay, it's fine, it's fine. So that means here we'll get 0.4 divided by 2.58 equal to square root of 0.36 divided by n plus 0.25 divided by 50. I have just substituted the values. Is this fine for everyone?
Yes.
Okay. Now, what should I do the next? What is the value of this 0.4 divided by 2.58? Anyone?
0.4.
0.55. 155.
Okay, fine. So this is the thing. Okay, don't worry about that much calculation. There will not be any question where it will not that much calculation. But yeah, we have to try to understand here. Now, what should I do? I can do the square of the both side, right?
Yes.
So thing is that we have to find the value of n. That is our main question. Okay. Now from here I can simply do the some manipulation and all. So 0.155 square. So it will be 0.024, right?
0.2. Yes, sir. 0.2.
Okay. Yeah, just correct me. And 0.25 divided by 50, it's a 0.005, right?
Yeah.
Now, so I can simply do 0.36 divided by n equal to 0.005 minus 0.024, which is nothing but I'm doing sorry,
minus 0.019.
one second. Let's not do like this. It's a correct incorrect.
Sir, this is opposite.
Yeah, it's opposite one. Basically, it will be 0.024 minus 0.005, right?
0.01.
0.019.
Now 0.019. Okay. So now from here it will be n equal to 0.36 divided by 0.019. Okay, which is nothing but it should be 18 point something.
95.
95. Okay, that means n is 19, right? You see, it should be an integer, right? Oh, okay, so is this clear? Procedure is clear?
Yes,
sir. Yes.
Yeah.
Yes, sir.
Sir, I have a query here.
Yes.
Just go up on
the double tail.
Yeah. Someone has query. Okay. Where?
Yeah. Sir, if you can just go up on this. This is a basic question on this. Like that where that we have put mod of the first line.
This one.
Yeah. Here. Yeah. Sir, here we are first is mod x bar minus y bar is more than c, and then I am putting this mu a minus mu b inside mod. Now mod x bar minus y bar more than mod x bar minus y bar minus mu a minus mu b is equal to is it same like if I put mu a minus mu b inside the mod?
Can you repeat? Can you repeat?
Yeah, I'll just tell x bar minus y bar is inside mod first, right?
Hmm.
And then I am taking mu a minus mu b and doing the deduction from x bar minus y bar mod, right?
No, you mean you are doing outside of the mod.
Putting this mu a minus mu b inside the mod side.
Initially, you are doing outside of the mod.
Inside the mod first.
Yeah, that is the same we have done, right?
How it is coming inside mod?
Okay, see, it's a basic thing, right? See, if you will do something, let me write here. Suppose I'm saying probability of mod of let's say z greater than a. Okay. Suppose just treat z as a x bar minus y bar. Okay, for example. Okay, that means what? You are doing z greater than a, or z is less than minus a, right? The same thing you can do x bar minus y bar greater than a, or x bar minus y bar less than minus a, right? Then you can subtract mu a minus mu b and mu a minus mu b for both, and you can do the aggregate manner. Got it?
No, like say, sir, what I was asking is,
See.
like say, let us take x bar minus y bar.
If you are getting confused, if you are getting any confusion here, right? Modulus of x bar minus y bar, why I'm writing inside the mu a minus mu inside the modulus, right? That is your query, right? Suppose.
Right.
Okay, I will clarify. Don't worry.
Suppose modulus if you can just take an example like x bar minus y bar is minus 2.
One second. This is something, right? The same thing I can write x bar minus y bar greater than c, or x bar minus y bar less than minus c. Yes or no? Correct?
Yeah.
Now what is the next? I have to subtract the mean, right? That means I have to do x bar minus y bar minus mu a minus mu b.
Fine.
Greater than c minus mu a minus mu b.
Yeah.
Or you will do x bar minus y bar minus mu a minus mu b, right? Less than minus c minus mu a minus mu b. Any doubt so far?
No.
The same thing. Now these things I can write in modular sign. That's all. Got it?
Okay. Okay, understood.
Understood? Yeah.
Fine. Yeah. Clear. Okay, thank you.
Yeah. So let me go with the just a minute. I'm erasing things so that we'll do in the whole things in the continuation. Okay, just a minute. Okay, fine. So let's move to the next question. Next question, that means I think question number it should be 11. Yeah, 11 and 12. Okay, so we have given waiting time in minutes of customers of a restaurant is exponentially distributed with unknown mean 1 by lambda, right? So if mean is 1 by lambda, then what is the parameter?
Lambda,
right? So question number 11 is saying waiting time is defined as x, which is following exponential lambda, right? I mean, it's given as mean 1 by lambda, and we know if any random variable is following exponential with parameter lambda, that means expected value of x, that random variable is 1 by lambda, right? Yes or no?
Yes.
Okay. So waiting time of last 5 customers, this is the one sample given to you, 15, 10, 5, 12, and 8, right? So we have given some sample, okay? And what is the, okay, let me write down the samples first. Samples will be 15, 10, 5, and 12 and 8, right? Okay. Now, if x is following exponential lambda, what is the PDF? Lambda into e raised power
Lambda x.
Right? X should be greater than 0, right? Now, question is saying we have to find the maximum likelihood estimate. So question maximum likelihood estimate, that means we have to find the likelihood. What is likelihood? Product of the all fxi, right?
Xi.
No. Tell me how many samples we have? 5.
Yeah.
Right.
Lambda to the power 5.
Okay, before we will do, yeah, let's do in proper way. Okay, that means if fx of x1, fx of x2, fx of x3 into fx of x4 into fx of x5. This is something we are doing while calculating the likelihood function, right? Now, what is the fx of x1? So lambda into e raised power minus lambda x1, lambda into e raised power minus lambda x2, lambda into e raised power minus lambda x3, lambda into e raised power minus lambda x4 into lambda into e raised power lambda x5. Yes or no?
Yes, sir.
Fine. Now, what is this? We got lambda raised power 5 and e raised power minus
lambda
minus lambda x1
into sigma x.
I mean, basically, I can do like this. Correct? Yes or no? Any doubt? So basically, lambda raised power 5, e raised power minus lambda, I will take common. Then I have to do the summation of each xi, right?
Yes.
I mean, this thing you can do directly while this was like that. Okay, lambda into e raised power minus lambda xi. This is the same case, but I have done so that you will get the idea. Okay, now this is ls lambda raised power e raised power minus lambda. What is meaning of this summation xi? From where I will get
All the samples.
correct. So this is basically x1, this is x2, this is your x3, and this is your x4, this is your x5. Correct. Now if you will add, how much is the 20, 30, 50, right? 50. Any doubt so far?
Yeah. Log of lambda.
I mean, any doubts? Is it clear till now?
Yes, sir.
Yes, sir.
Fine. What's
Yes,
the next
sir.
step? I have to take the log, right? Natural log of this. Then it will be 5. Basically, let's do log raised power log of lambda raised power 5 plus log of e raised power minus 50 lambda, right? So next it will be 5 log.
Sir, it is land or log?
Basically,
Natural
it's the same. See. I will tell you. This is log with base e. Okay, which is same as ln. Okay.
Minus 50 lambda.
Okay, so if I have something log of e raised power s, this is same as x, right?
Yeah.
With base e. Now what is x? X is I have minus 50 times of lambda, right? Yes or no?
5 by lambda.
Okay. So log of L is nothing but 5 log lambda minus 50 lambda. Any doubt till now?
No.
No, sir.
No. What's the next step? I have to differentiate with respect to lambda. So it will be 5 by lambda minus 50 equal to 0.
0, yes.
Now what's the next? It's 5 by lambda equal to 50. So lambda will be how much? So 5 by 50 equal to lambda. So basically lambda cap will be 1 by
0.1.
So it will be 1 by 10, which is nothing but 0.1, which should be the answer. Any doubt? Is this clear?
No.
I mean, not clear or no doubt?
No doubt.
Okay, fine. Okay, so next is find the posterior mean of
Also,
lambda. Yeah,
asking about the last step.
Yes.
Yeah, in that sheet, it was log L divided by the lambda. Then we have equated it to 0, right?
Yeah, we have differentiated with respect to lambda.
Okay, got it. Okay, got it.
Got it? Yeah. Fine, clear? Okay, so next question is saying find the posterior mean of lambda using the exponential 1 by 10 prior. Now, to find the posterior mean and all, what's our approach? What should be our approach?
Likelihood is defined.
I mean, that is nothing but something we are doing Bayesian estimation, right?
Yes.
Means I will be having some prior information for my parameter, right? Now, I'm not going to consider my parameter as a constant. As per the Bayesian approach, there will be some prior information for my parameter, right? It can be any distribution, it can be uniform, it can be Bernoulli, it can be beta, exponential, anything, but that prior information will be given to us. Now, one prior information is given to me for lambda. It's exponential 1 by 10. Okay, let's go with by the exact procedure, right? So I have one prior information, what it says, this lambda is nothing but exponential 1 by 10, right? This is the one information I have. Now this lambda is nothing but our random variable now, right? It's not a constant. Okay, what will the PDF f lambda?
1 by 10.
1 by 10 into e raised power minus
Minus 1
lambda by 10.
Hmm.
This is clear to everyone? Yes or no? Right? Now we have been asked about posterior. So we know posterior is nothing but proportional to likelihood times prior. Yes or no?
Yes, sir.
And what is the likelihood? We have calculated in the previous question itself. It's just a continuation part. So likelihood is what? Likelihood this part, right? Lambda is for 5 into e raised power minus 50 lambda. So lambda is for 5 into e raised power minus 50 lambda. Any doubt till now? And what is the prior? Prior is this. So 1 by 10 into e raised power minus lambda by 10. Is this clear?
Yes, sir.
Now, you know, this is the constant we are not using the equality sign. Then this, yes.
So the prior is 1 by 10 e power of minus 1 by 10 into x.
Yeah,
Lambda
here instead of x, I have lambda, right? Lambda we are going
So
to
we have
consider as a random variable.
Okay, sir.
Okay, here lambda is not a parameter. Lambda is not a, I mean, constant value. It's a itself it's a random variable. Okay.
Okay.
Since
So
here, yeah, good.
Exponential of parameter is 1 by 10. 1 by 10 e power of minus x for a.
See, instead of x, you have lambda, and at the place of lambda, you have 1 by 10. See, what is the PDF of exponential distribution? It's
Lambda into e power of minus
lambda x, right? Where lambda is a constant. Instead of lambda, I have 1 by 10, and instead of x, I have lambda.
Okay, sir.
Clear? Now this 1 by 10 will be this under proportionality sign. Now we will be having lambda raised power 5 e raised power minus 50 lambda minus lambda by 10. Can I do or not? Right? So it will be e raised power minus lambda I can take common. It will be 50 plus 1 by 10. So far so good. Any doubt? E raised power minus lambda 50 plus 0.1. Can I do? Lambda is for 5, it will be e raised power minus lambda 50.1. Any doubt so far?
No, sir.
So posterior is proportional to lambda is for 5 into e raised power minus 50. Okay, what kind of distribution this one?
Gamma distribution.
Correct. So this is the gamma distribution. So posterior distribution is nothing but gamma distribution, and parameters are 5 comma
minus lambda.
Okay, first of all, it should be 5.
Minus
6.
Correct. Actually, it's a basically, if you go for gamma distribution, it's a PDF of, let me write down that PDF of gamma distribution. Let's say, suppose I'm saying x is following gamma, alpha comma beta. I'm not writing the constant. It's a proportional to x raised power alpha minus 1 into e raised power minus beta x. Okay. So it should be, so this 5 I can write down 6 minus 1. Okay. So parameter will be, let me write down on the next page. Is there? So parameter will be gamma 6 comma 50.1. Okay. This is the parameter. Okay. Now, what is the posterior mean? My question, our main question was posterior. So in case of gamma distribution, mean is alpha divided by beta. So alpha is 6, beta is 50.1, which is nothing but I can solve it. 0.12. So this should be the answer. Let's check. Yeah, 0.12 inside the range. Okay. Is this clear?
Yes, sir.
Fine. So we can move to the next part.
Yeah.
Okay. Now I think question. Okay, how many of you doubt in this question? Should I do or it's fine?
No, do, sir, do. Done.
Okay, I should do.
Yeah.
I mean, anyone of you have difficulty in that question? Okay, no problem. Let me do it itself. Okay. So x is the continuous random variable with PDF fx c6x 1 minus x, right? So PDF is 6x 1 minus x, and support of x is 0 to 1.
Sir, is it that we have to just integrate the PDF
Yes,
from
yeah,
0
that's
to
all.
1?
That's all. That's why I asked.
It
Okay,
is
how will you
easy.
define your fx? That means, so there is rule. I mean, not rule, kind of. I mean, before x less than 0, it will be 0, right? And after x greater or equal to 1, it will be 1, right?
Yes,
I
sir.
mean, that means we have to find the between case, right? Yes or no?
Yes, sir.
See, always CDF will start from 0, and I mean, your range of your CDF is nothing but 0 to 1. Okay. So we'll fill this case. Let's see what is the CDF. So this is nothing but probability that x less or equal to x, right? Now we have to integrate. What is the lower limit of x is?
0.
0 to x, right?
1.
We have to, not 1, it's x.
X, sorry, sir.
Okay. So it will be, we have to integrate 0 to x, 6x, 1 minus. I think this is very simple integration. I mean,
Yes.
okay, let it be, because see, I was not about to solve because you guys have some session, right? It will be 0 to x, right? So I can take x
Yes,
dx minus 0 to x square dx, right?
I think this is the easiest question given.
In mock.
Yes.
Okay, no problem. Okay, let me do it. No, anyway, I have to do it. This one. Okay, this is something 0 to x, right? Okay, again, I think you will get the same value, right? 6. Anyway, if you put x square by 2, 0, it will give you 0. This is x cube divided by 3. So it will be 6, 3x square minus 2x cube divided by 6. 6 will get cancel out. So you got 3x square minus 2x cube. For what? When x is 0 to 1. So just fit this value. I mean, this would be 3x square minus 2x cube. Is there any value option?
Yes, sir. Fourth option.
Fourth option. Yeah, here, I mean, you can take x square as a common, right? So it will be 3 minus 2x. Is this clear?
Yes, sir.
Okay. You can take x square as a common, you will get correct answer. Just give me a minute, I will be back in 1 minute, okay?
भाई गाना कौन गा रहा है?
गलती से माइक ऑन रह गया था, सॉरी गाइस.
ठीक है.
It says our preparation is really good.
Hello. Yeah.
Hello, sir.
Yeah, I'm audible, right? Yeah, let's move to this part. I think this is, we have to find the maximum likelihood estimate of sigma, right? I mean, approach is the same, okay? PDF is given to us. This is question number, I think it should be 14. So PDF is given to us. Okay, so it's 1 by 2 sigma exponential of modulus of minus of x by
Modulus x.
Sigma, and range, I mean, support of x is minus infinity to infinity. Basically, we have to find the maximum likelihood estimate of sigma. Okay, so we'll do in general. Okay, and then it will put the value of I mean, this x size, I mean, all the sample values at the end. Will that be okay? Okay.
Yes,
right?
sir.
Okay. So what? Okay. So first of all, you have to find the estimate of sigma. That means by the maximum likelihood function. I mean, at the end, I have to differentiate with respect to sigma. Okay.
Yes.
That is, I mean, okay. So what is the likelihood? How many samples we have given? 10, right? 1, 2, 3, 4, Yeah, 10. Correct. So we have given 10 samples. So 4 minus 2, 2. 1 minus 4, 5. Minus 1, 2, 3, 6. Okay. So we have total 10 samples. Yeah, 10. So likelihood is nothing but product of till 10 all effect size, right?
Yes.
Okay. Now tell me, that means product of I is equal to 1 to 10, 1 by 2 sigma exponential of minus x by sigma, right? Now it's then I can write down xi. Yes or no?
Yes.
So if I will expand, then I will simply write 1 upon 2 sigma raised power 10, because I have to multiply till 10 times. Because are you getting? Okay, what's the e raised power? So basically this is nothing but e raised power
30 by sigma.
Minus x1 by sigma modulus minus x2 by sigma up to minus x10 by sigma. Yes or no? That is something, correct? So 1 by 2 sigma raised power 10 into e raised power minus is 1 by sigma if I will take, that means modulus of x1 plus up to modulus of x10.
Yes, sir.
Correct? So that means what is this? This is just addition of all the sample values, right?
Samples, yes.
And since all are in modulus, that means this all the negative sign will be in positive. Yes or no?
Yes, sir.
Correct. Then what is this total? 4 to 6 to 8, 9, 30, 18, 19, 21, and 30, right? Everyone is getting right. Why I'm ignoring the minus sign? Because if you write minus 2, that means 2. Correct.
Yes.
So it will be 1 by 2 sigma raised power 10 into e raised power minus 30 by
sigma.
So far so good. So what's the next step? I have to take the log. So log, if you take the log, so it will be 1 by 2.
Constant 0 here.
Okay. Before that, I can take 1 by 2 raised power 10 into 1 by sigma raised power 10 into e raised power minus 30 by sigma. Yes or no? Correct. Next, I have to take the log, right? So that means log of, let's 2 raised power minus 10 plus log of sigma raised power minus 10 plus log of e raised power minus 30 by sigma. Any doubt? Anyone?
No, sir.
Clear? These things I can do 10 minus 10 log 2 minus 10 log of sigma minus 30 by sigma.
Yes.
Because if you do log of e raised power x, nothing but x, right? And instead of x, I have minus 30 by sigma. Is this clear?
Yes, sir.
Yes, sir.
Okay. What's the next? I have to differentiate with respect to sigma. It will be 0 constant. It will be minus 10 by sigma and minus 30 by
2 sigma square.
2 sigma square.
2 sigma square.
Minus 1 sigma square. Because differentiation of, let's say, x, I mean inverse of x is nothing but minus 1 by x square. Okay. Is this clear, everyone, for everyone?
Yes.
Yes, sir.
So next step, I have to equate this as a 0. So it will be minus 10 by sigma plus 30 by sigma square equal to 0. It will be minus 10 by sigma equal to 30 by sigma square. 1 will get cancel out. So it will be sigma. We have made mistake.
Sigma is minus 3.
Not minus 3. See, if you equate with 0, it will be positive.
Sigma
right? So sigma equal to 30 by 10, which is 3.
3.
Correct. So sigma had ml as a 3. This is the answer. So basic thing is you have to just multiply all the probability, right? Is this clear?
Yes, sir.
Yes, sir.
So let's move to the last. I think this is the last two questions. Yeah. So question number 15, right? Let's say, let me read what question is saying. So question is, suppose the number of diseased people in a week because of deadly disease. Okay, diseased people, sorry. disease in a country has the Poisson lambda distribution. A researcher wants to estimate the lambda from the studies in other country. Prior mean should be 3. See, we focus with the statement. He said prior mean should be the 3 and the prior standard deviation is 1. He decided to use the gamma alpha beta prior. Okay, so prior is what? Now what is the, so prior here I'm talking about lambda, right? Correct or not? So he's talking about lambda. Prior is what? Gamma with parameter alpha beta, and they are saying mean is 3 and standard deviation is 1, right? Standard deviation is 1, that means variance is also 1. Yes or no?
Yes, sir.
Then he says that prior, that matches his prior mean and standard deviation. Okay, the number of okay. So they have recorded over the 10 weeks 357. Okay, they have recorded these number of people, right? Now before that we have to find the value of alpha and beta. Now what is the, in case alpha mean, in case of gamma distribution it's alpha by beta. Yes. And what is the variance? Alpha by beta square.
Yes.
Correct or not?
No.
Yes,
From
sir.
here I can find the value of alpha and beta because we need to find the value of alpha beta. Then here it will be alpha equal to beta square. Correct. From here alpha is what? 3 beta. If you put this alpha 3 beta here, so 3 beta equal to beta square. So that means 1 beta will get cancelled out. Beta is nothing but 3. Yes or no? If you put beta as 3 here, that means alpha is 9. Correct. So we found the value of this. So we have, I think option number D is the correct, right? So we have value of, now we have information lambda is gamma 9,3. That is the information we have now. Yes or no? Correct?
Yes, sir.
Now, one information says X is following, I mean that number of decades people in a week is following, what is, okay, posterior mean we have to find. So that before that we have to find the posterior distribution. Okay. So that X is following exponential. So this is your prior information, right? X is following what? Poisson distribution with lambda. What will the PMF? E raised to minus lambda raised to X divided by
X factorial.
Right? How many samples we have given?
10 samples.
Okay, let's do in general first of all. Okay, we know posterior is nothing but proportional to likelihood times prior. Correct? And what is the likelihood? First of all, I have to find the likelihood. Likelihood is what? For this case, see, likelihood, your likelihood will be product of I is equal to 1 to n e raised to minus lambda raised to xi divided by xi factorial, right? Likelihood will be for sample. Yes or no?
Yes, sir.
Yes, sir.
Prior is what? It's a gamma.
Gamma.
Right? So I'm okay. What will the gamma?
Gamma is gamma.
Lambda is for alpha minus 1 into e raised to minus lambda beta. Right? We know the value of these two. I'm just writing in general. Right? So far, so good. Okay.
Yes, sir.
Now, these all constants, since I'm not using the equality signs, right? Proportionality sign means we can ignore the constant value, right? Then I can, you will get e raised to minus n lambda.
10 lambda.
E raised, then see, I'm talking about in general. Let's proceed in this manner, okay? Then lambda raised for, basically you will do x1 into lambda for x2 up to lambda for xn, right? So basically what we are doing, we are we can add the powers.
X1 plus x2 plus
Yes.
xn.
So it will be summation of xi. So far so good. Any doubt?
No, sir.
Okay. Now I have lambda is for alpha minus 1 into raised for minus beta lambda. Now if you see, this is proportional to lambda is for, I can say alpha plus summation of xi is minus 1 into e raised for minus n plus beta lambda. So far so good?
Yes. Yes.
So what kind of distribution this is? This is again
Gamma.
right? So posterior distribution is nothing but again gamma. What is the parameter? Alpha plus summation of xi and n plus
beta.
So far so good,
So n plus
right? Any doubt?
No, sir.
What will the posterior mean?
Alpha.
Alpha by beta. Now in the at the place of alpha, I have alpha plus summation of xi, and beta is n plus beta. Now what is the alpha? Alpha we got 9. Summation of xi means we can add all the sample values 357017. Let me write down. So each xi, I mean xi's are 357 017. Can anyone can add please? 4964.
749.
सर 15 को 16 16 सर 23
7496.
46.
46?
Yes,
Fine.
sir.
No, 6.
Yes, sir. 46.
Okay, so summation of xi is the 46 and n is 10 and beta is 3, right? So that means it's the 53 divided by not 53, 55.
55 by 13.
55 by
13.
13, then it will be, if you it should be something 4 point something, right?
4.23.
4.23. Okay, nice. So this is the answer. 4.23 I say inside the range. Is this clear?
Yes, sir.
Yes.
Okay. Any doubt in this question?
No.
Okay, so you got the concept. Okay, so you can expect that you can expect as a hint or something the first two questions.
So the previous page I would like to see.
One second. Alpha and we solved that question, right? First to find the alpha and beta in terms of C. Then that method of moment question, you can expect this kind of question in your intermediate. Yeah, which your doubt?
So the previous page I just had
yes,
one
yeah,
problem.
Sure. No
Alpha plus sigma xi minus 1.
Yes.
So that will be 46 plus 9 minus 1. No?
46 plus 9 minus 1. Yes.
9, huh?
Yeah. Then it will be, see, anyway, this is 9 plus 46 minus 1. So this is the 55. This is the 55.
Oh.
Okay. I mean, here I have done in general so that we should
Okay.
Sir, can you repeat the hint?
N is 10, no?
Yeah, n is 10. So here, if you see, I have substituted the value of n as 10. Summation of xi is 46, alpha as 9, beta as 3. Understood?
Yes.
Okay. Yeah.
Sir.
Yes.
Sir, can you like repeat the hint what you were talking about?
Where?
Sir, which type of questions will come and all?
Okay. I mean, it's not the question will be same. I'm just telling you giving you just some idea. The first question, right? You saw find the alpha in terms of C, beta in terms of C. Method of movement we have solved questions, right?
Yeah.
So you can expect just try to practice those kind of questions and this posterior and all. Okay. So just step. Okay. So you have seen that formula sheet. Okay.
Yeah,
be
sir.
ready with. I mean, this formula sheet will be provided to you. No need to memorize any formula. Okay, you can see this formula sheet. Okay, so these every formula will be provided to you, right? All test in which they see if your null hypothesis is this kind of alternative this, then what will be your rejection region, what kind of test statistic you have to take, all the things will be provided. The only case is you have to follow you have to identify and you have to apply. That's all.
Sir, one more question. In the mock test, I haven't seen any question from Chebyshev inequality or CLT, whatever.
Okay, it doesn't mean there will not be any question. Okay, so actually in mock it was basically your content will be from 1 to 12. That's all.
Okay. Yeah, but in the revision session, the professor said about like the weightage and all. So there is like
Okay,
only.
you can I have posted the week weightage on the discourse. You can explore that one also.
Okay, sure.
Sir,
okay, everything is fine.
Question 6 once.
Question number 6.
Yes, sir. That p value one.
You should ask at the same time, right? I think. Scroll up more and more. Yes, where is your?
Sir, can you consider F distribution?
Yeah, what is your doubt? Question number 6.
Sir, this how you got the normal for test statistic?
Okay, what is the central limit theorem says?
CLT.
The number of samples increases, the more it tends to normal.
Normal distribution, and in case of statistics, if n is greater than 30, we are taking, in some books it's taking 50, but normally we are taking 30. It's considered as a large sample. How many samples we have? 75. That means it will convert to normal or not?
Okay, sir. Yes.
Okay, fine.
Got it.
Yeah. Okay, so
In the last question, we'll get alpha as 56, no?
alpha is not a 56. Alpha is a 9.
Oh, alpha is 9.
We have calculated, right? Here, if you see alpha is, we have calculated 9.
Alpha is 9, right?
Yeah, okay.
Alpha is 9. But the posterior distribution is what here?
4.23.
No. That
Posterior
is the
distribution is gamma. Posterior mean was 4.2.
Achha, that will be alpha plus sigma I.
Yeah, so here,
Sigma
see,
xi.
this is your whole alpha. This is your whole beta. Understood?
This is the final alpha and beta.
Alpha and beta means your 2 parameters of a gamma distribution. Okay.
So alpha plus sigma I xi will be 55, isn't it?
Yes. Yeah. See, I have done the whole calculation at the last. You can do the same thing here itself, right? You can put all the xi here. You can put the alpha here. You will get 9 minus 1. You will get 3 minus 3 lambda. At the end, you will get the same answer. You can try that. Okay.
No, but then when we are calculating the mean, we will have to consider the alpha as alpha plus sigma.
First of all, let me clarify. Don't memorize alpha. I have to take only alpha. I have to take only beta.
No.
Okay,
what I was trying to understand,
I
was trying to understand that posterior distribution which we have got.
One second. I will. One second. Don't worry. I'm there. Okay. See, suppose I'm saying x is following gamma, alpha, comma, beta, right? Then mean is nothing but alpha by beta. That is this parameter divided by this parameter, right? Now I have the first parameter alpha plus summation of xi. So posterior mean will be just considered as a alpha dash. This considered as a beta dash. Okay. So your mean will be alpha dash divided by beta dash.
Beta dash.
So alpha dash is alpha plus summation of xi and beta dash is n plus beta. So those whole things as a alpha dash and beta dash. Is this clear? Right? That was your question, right?
No.
Sir, I think she is
I
confusing.
got this lambda raised to 46 plus 9 minus 1. No?
Minus
lambda
1.
raised to 46
See,
plus
if you are
9 minus 1.
getting lambda raised for one second. Lambda is for 1 second. Lambda is for 46 plus 9 minus 1, right? Correct? Then what will be your parameters?
The alpha dash will be 46 plus 9.
46 plus 9. What will be your dash? What you got here? E raised to minus
10
13 beta.
plus 3.
That
10
is
plus 3.
10 plus 3.
Okay.
The same thing I have done, right?
Okay.
Okay, it's not. It will not affect the answer. Okay.
Okay.
The only case different was I had done in the general way, and I have substituted the value at the last. Okay. Fine.
Yes.
Okay.
Okay.
Is it clear?
No, I was not understanding how we got that.
Okay. Now it's clear, right?
Okay. Yes.
Okay.
Yes,
Okay.
sir.
Fine.
Thank you, sir.
Sir,
Thank you.
Yeah.
Sir, I have a quick query in two variable F test, if I may ask you.
Yes.
Yeah. So can you open the formula sheet, sir?
Formula sheet. Okay.
Yeah. So if you go to the two variable F test, right?
Yeah.
I mean, not this one, not.
Yeah, this one. This is the...
Yeah. So the last two-tailed one. Okay. See, I mean, what we say is S1 square by S2 square greater than 1 plus CR.
Yes.
Will be equating to lambda by 2.
Lambda by 2 is not alpha by 2.
Alpha by 2. Yeah, correct.
Yes.
Alpha by 2.
Yeah.
And we also say like alternatively it can also be said like less than 1 minus CL alpha.
Yes.
By 2, right?
Yes.
So now my question is like, see, now when we take alpha by 2, I mean, my S1 square by S2 square is going to be same constant based on the sample that is given, right? and alpha by 2 also will be going to be the same based on the significance that is given to us.
One second. It's not okay. Don't compare S1 square divided by S2 square is alpha by 2.
I mean, we say we take that F inverse of that, right?
See, okay, actually, it's not. Are you saying S1 square divided by S2 square as alpha by 2?
No. We see we equate probability of t greater than 1 plus CR.
Correct.
Then we take actually the inverse of the alpha by 2.
Yes.
Using the F sample, whatever.
Correct.
Okay,
Yes.
table will be given. So that value we'll see like, okay, because we say t is greater than 1 plus CR, we check that S1 square by S2 square is greater than
1
the
plus
inverse of alpha by 2.
Yes. So I mean, you can do any one.
But
greater than sign or with the less one sign.
So it will be both same, is it? Like, because see now
that's why it's alpha by 2, right?
Yeah. Okay. See now, whatever, irrespective of whatever I take, sir. One question is like,
okay. Basically, I will tell you how will you compute the significance level in case of F distribution. Okay. Suppose this is the case, right? Suppose this is your at 1. Okay, and this is your suppose this is 1 plus CR. Okay, and this is suppose 1 minus CL. Okay, for example, this means this is CL. This range is CR, right?
Yeah.
So when you will reject H0 here? I mean, this case, suppose I'm going to reject H0. That means my T is greater than 1 plus CR.
Correct. Yeah.
And for this case, T is less than 1 minus CL, right?
Correct. Yeah.
Okay. Now let's do the by graphically. If you see, so if you do the graphically, basically both will give you the alpha, both, because rejection should be alpha, right?
Right.
That means this will cover alpha by 2. This will cover alpha by 2.
Yeah, that's correct. Yeah.
Okay. So that's the same thing we are saying. Alpha by 2 is same as probability of T is greater than 1 plus CR under H0. This is same as probability of T is less than 1 minus CL under H0. That's
okay. Maybe, I mean, I don't have the exact example what I was looking at, but one thing which I noticed is like when we take, if it is T is greater than 1 plus CR, so we have to take probability of, I mean, 1 minus P T less than 1 minus CR. Then we actually subtract that with alpha by 2, and then we'll take F inverse, right? That's what we will take.
Can you repeat? Sorry, I did not get your point.
If you take an option like T of T greater than 1 plus CR,
okay,
that we will write it as 1 minus T less than 1 plus CR, right?
Yes. 1 minus, yeah, that is something you're talking about, right?
Correct. Yeah, 1 plus CR.
Fine.
Then we will do probably
1 minus, let's say FT 1 plus CR.
Right, 1 plus CR equal to alpha by 2.
Yes, equal to alpha by 2.
So which is like 1 minus alpha by 2 F, which whole we will take FT inverse.
Correct. Okay. Fine.
I mean, some sample which I was looking into, some, I don't know which exact question number, but when I took this one, the FT of 1 minus alpha by 2, that's
basically you have to no. It will be 1 plus CR equal to FT inverse 1
inverse
minus
of 1 minus alpha by 2. Correct.
Yeah.
So when I do this one and 1 minus CL, when I do, both were not actually matching.
No, it should match. Maybe you are doing any mistake. If okay, what you will do, if you got the question, just post and tag to me. I will check it.
Okay, sir. Sure. I'll check that. Yeah, I forgot the question number.
No problem. Okay. Okay.
Yeah. Thank you.
Okay, then all the very best to all of you for your
can I consider app test for the enter?
Yeah, it's in syllabus. So
thank you, sir.
Okay. Okay, all the very best for your exam. Okay. So
thank you, sir.
I'm hoping
thank you.
Thank you, sir. Thank you, sir.
You learned something from us. I'm just hoping that same thing.
Quite a lot.
Definitely, sir.
So,
sir, you are Prashant, sir.
Thank you, sir.
Yes. How would you know?
Sir, from your voice is very amazing. It doesn't look like.
Fine. Thanks.
Thank you, sir.
Okay. So
thank you, sir.
I'm hoping you guys will clear the exam with some flying colors. Okay. So it will be
definitely,
good for us
sir.
if you are providing some feedback about end term exam and whole syllabus on the discourse. Okay. So just give your feedback, or is there any suggestion which we can implement in the course? That will be great for your juniors also. Okay.
Sir, TA sessions should be regular. Just that.
Okay. Fine. Okay, we'll take care of it. Okay.
Thank
Okay,
you,
then.
sir.
Thanks everyone. We'll meet soon. Okay. Thanks. Bye.
Thank you, sir.
Thank you very much, sir.
Thank you. Bye.